Hi, this is Mrs. Hedden, and this is using Kepler's third law. Some examples. So the example we have is planet Pluto is 39.5 Earth distances from the Sun. How long does it take to go around the Sun once? And there's Kepler's third law, and there's not a lot of information. So you have to be careful going ahead and doing this. And the best technique is to go ahead and write out what you know using the guess method. So we have 39.5 Earth distances. Well, what is a distance from the Sun? Well, that's simply a radius. So we know the radius. Okay, we know the radius of Pluto is 39.5 Earth distances, or I call it Earth radiuses. And if we look at a quick sketch, this is obviously not to scale. Here's my Sun, here's the Earth, here's Pluto, and the distance of the Earth to the Sun, that's an Earth radius, okay? And we're talking about radius not of the Earth itself, but the radius of its orbit. And then we have the distance from the Pluto to the Sun, and that's equal to 39.5 Earth radiuses. So we know radius of Pluto, 39.5 Earth radiuses. We want to know how long it takes. How long is the period? So we're hunting for the period of Pluto. Now, to do this, we have to compare Pluto to some other planet that orbits the Sun. And since we're already in Earth radiuses, and the Earth does indeed orbit the Sun, we can compare it to the Earth. So I'm going to go ahead and say the radius of the Earth. Well, how far in Earth radiuses is Earth from the Sun? Oh, it's 1 Earth radius. And since we're comparing it to the Earth, we would need to know the period it takes for the Earth to orbit the Sun. And how long does it take the Earth to orbit the Sun? Well, it takes 1 Earth year, so let's just use Earth year units. Okay, now we've got everything written out, our knowns and unknowns, so then it's just a matter of plugging and chugging. It's usually a good example to put your unknown on top. Makes it much, much easier. So we have here the, we're hunting for the period of Pluto, how long it takes to go around the Sun. We have in here, or on this side, the radius of Pluto, how many Earth radiuses it is for the Sun cubed, over 1 Earth year squared on this side, and 1 Earth radius cubed on this side. So TP, we take 39.5 and cube it, getting 61,629.9, and then we square root it to get TP. That's 248.25 Earth years. Next example, it takes Jupiter 11.87 Earth years to orbit the Sun. What is the average distance of Jupiter from the Sun in Earth radius units? Again, I'm going to draw a real quick sketch of this. So we know how many Earth years it takes Jupiter to go around the Sun. We're hunting for the distance from the Sun to Jupiter in Earth radiuses. And we know the Earth is, in Earth radiuses, 1 Earth radius from the Sun. And again, we're talking about radiuses here. We're talking about the radius of the orbit, not the radius of the planet. So again, I'm going to use my guess method and write stuff that I know. It gives me the period of Jupiter in Earth years, and I'm hunting for the radius of Jupiter, and again, I'm hunting it for in Earth radiuses. I have to compare Jupiter to another planet that is orbiting the Sun, and another planet that orbits the Sun would be the Earth. So I need to find the period of the Earth in Earth years. Oh, it takes 1 Earth year for the Earth to orbit the Sun, and the radius of the Earth in Earth radiuses, and the Earth is exactly 1 Earth radius from the Sun. Okay. Okay, I've got all my knowns and unknowns. Now it's just plugging it into the equation. Okay, again, my equation is just comparing the period squared of one object to the period squared of a second object, and that's equal to the radius of the first object cubed divided by the radius of the second object cubed. And it's really much easier to put your unknown on top. So I'm going to put Jupiter on top because that's what I'm hunting for. So I've got 11.87, the period of Jupiter squared, divided by the period of the Earth squared, and it's equal to the radius of Jupiter cubed divided by the period of the Earth cubed. 1 squared and 1 cubed is easy, so now I just have to do the other math. So 11.87 squared is 140.897. I'm going to take the cubed root of that and the cubed root of my other side. And I get the radius of Jupiter is 5.2 Earth years. It's good to note that in your calculator, to take the cubed root, what you can do is enter in that number, 140.897, and then caret to the, and then I always use parentheses because I'm being careful, to the 1/3, and 1/3 is the same as the cubed root. And for some calculators, that's an easier way to go. So that's enough examples. Unfortunately, we're not always going to be comparing to the Earth. It is presumed that you understand that it takes the Earth 1 Earth year and it's 1 Earth radius away from the Sun. You always have to compare it to something it's orbiting. So if instead of something orbiting the Sun, you have something orbiting a planet, you can't compare it to the Earth. Let's look real quickly at one more example. Here we've got Mars has 2 moons, Phoebus and Deimos, Fear and Panic, the companions of Mars, and it's got this stuff in minutes, and it's got this stuff in distances. There's a distance missing, which I took out. We'll add that later. But the important thing is that you're going to have to compare them to each other. We've got Mars here, and we've got Deimos, and we've got Phobos, and they are orbiting Mars, and so we're going to have to compare them to each other. So we need to know that distance from the center of Mars. Oh, there it is right there, the distance. Okay, so we have Deimos, and its distance is actually in a kilometers unit, so we're kind of used to it, 2.3 times 10 to the 4th kilometers. And we're trying to find the distance this guy is. Okay, so we're going to compare them. We also have the period. We've got it in mixed units of hours and minutes. We're going to have to convert all that. Doesn't matter which way you convert. You can go to hours or you can go to minutes. Usually it's better to go to the smaller unit. So we've got to convert that to all minutes. So 30 hours. Using some dimensional analysis. So the period of Deimos, is equal to 18 minutes. I need to know the period of Phobos. So let's do that. I've got 7 hours is 420 minutes. I'm going to add the other 39 minutes to that. And that's the period of that guy. So now I have to compare them. So my unknown is the distance for Phoebus. So I want to go ahead and my radius of this guy is my unknown. My radius of Deimos is 2.3 times 10 to the 4th kilometers. So now I'm just going to plug it away. So I've got this, my unknown, so I'm going to put this guy on top. So I have 459 squared divided by 1818 squared is equal to the radius cubed, which is what I'm hunting for, divided by the other guy, 2.3 times 10 to the 9th cubed. And now again, it'll be really nice to have a calculator. So then working out the numbers, that looks pretty good. You've got an example. Unfortunately, things are not always 1 in the denominator. Sometimes you have bigger numbers that you're going to have to work with. Thank you very much for your time. Goodbye.